Hello friends, today another problems I will also explain. Okay, so today problem is design a 4-bit combinational circuit decrementer using 4 full adder circuits. Okay, that means we have to consider 4-bit combinational circuit which is a design for decrementer. Two kind of things, incrementer or a decrementer. So we will consider a 4-bit combinational circuits for decrementer using 4 full adder circuits. Okay, so this is our problem. So now I will discuss or I will explain this 4-bit combinational circuit, how the decrementer will consider or will design with 4 full adder circuits. Okay, before design this one, I will explain what the concept of a circuit, what the concept of a decrementer. Okay, after that I will design the 4-bit combinational circuit. Now see, decrementer means what? First question is decrementer means what? Decrementer, the role of a decrementer is decrease the value by 1. That is the decrementer. Similarly, if we go through incrementer, that is increment value by 1 is called as incrementer. This is the basic concept of a decrementer and incrementer. For example, take one example. A is a data, any data, 4-bit data. Suppose here we mentioned 4-bit. A is a 4-bit data. If we go through decrementer, then definitely A minus 1, it will decrease by minus 1. Okay, since it is a decrementer, minus 2, minus 3, minus 4 we can take it, but normally we will consider that is a minus 1 for a decrementer and that is a plus 1 for an incrementer, because this is the basic concept. Other data we can take it, but that is other purpose we can use, but decrementer, incrementer we will design in this manner. Okay, so if we go through this particular A operand or A data minus 1, how it will evaluate? That is the major question. How it will evaluate? That is A minus 1. That means I will explain, then you can understand. See, that is A, we can write A value. But whenever I go through minus 1, we have already discussed, or you can see that is a different concept of a minus value. Minus value means that is a 2's complement of 1 plus 1. This is the basic concept. Okay, that is a 2's complement of 1. 2's complement of 1 means what? Here minus 1 means, there minus 1 means 2's complement. Okay, 2's complement of 1, then we can tell as a minus 1. Okay, that means what? 2's complement of 1 means we can write 1's complement plus 1 we can call as a 2's complement. Remember, any value minus, suppose we will consider, then what happens? Minus value we can design through 2's complement. Here minus 1, that means a 2's complement of 1. Okay, if we go through suppose minus 5, for example, minus 5 means 2's complement. Okay, 2's complement of 5. What is the value? Digital value we can see. Okay, minus 5 means 2's complement of 5, means that is 1's, okay, 1's complement of 5 plus 1. This is the basic concept. Okay, 1's complement of 5 plus 1. Here the question is, whenever you take 1's complement, 2's complement of 5 or 6, 7, 8, 9, actually that is not determined by normal numerical value or particular decimal value. We will consider only binary value of that, either 1's complement or 2's complement. Okay, don't go through 10, 20, 30 2's complement, that is wrong. we can actually define through binary value of that 5. Suppose here consider 5. That means binary value of a 5. For that binary value, we consider 2's complement of that 5 binary value of 5. Then we will consider that is how it will be defined. Okay, this is the basic concept. Okay, now we see how it is designed or how it is defined. Okay, so one thing we can see, suppose here 5, what is the minus 5? For example, we can take it. Suppose we can take minus 5 here, minus 5. How to define? Okay, minus value, how to define? Simple, minus 5 means, you see, what is the value of 5 first? 5 means what? You see, here is 5 value is, suppose 4 bit 0, 1, 0, 1. This is the 5 value. If we go through minus 5, that means 2's complement of minus 5. If we go through 2's complement of 5, then what will do? 1's complement plus 1. That means 1's complement of this plus 1 is known as minus 5. That means here you see 1's complement means 1, 0, 1, 0. 1's complement. Again plus 1 add. Okay. Because 1's complement plus 1 is a 2's complement. Then what happens? 0, 1, 1, 1, 0, 1. Okay. This is the, what happens? That is a minus 5. If we go through this is simple, it is minus 5, 1, 0, 1, 0, 1, it is not minus 5. The 2's complement of this is called minus 5. That means this number is the minus 5. Okay. In this way, we can define any number, okay, minus value, that is a 2's complement of that number, that is binary number of that number of that number based on 2's complement. So 2's complement of that number, and the 2's complement to that number means 1's complement of that binary number plus 1. Okay, like I told, what is a minus 5? That means minus 5 means first 5 we are defined. 5 binary form of 5 is 0, 1, 0, 1. And how to define this minus 0, 1, 0, 1? That means 5 you define this one. 1's complement, we have to define 2's complement of this number. That means 2's complement means first 1's complement plus 1. 1's complement means 0, 1, 0, 1. Okay, that is 1's complement. Again 1, 0, 1, 0, 1, 0, 1 is equal to 5. 1's complement is 1, 0, 1, 0 plus 1, because 1's complement is this one plus 1 this one, then you will get 1, 0, 1, 1. This is the minus 5 value. This is the minus 5 value. Similarly, whenever you go through this particular incrementer or decrementer, suppose we go through, our question is a decrementer, then we can define this value a minus 1. A is any value that is 4-bit value we can consider, doesn't matter. Then a minus b, a minus 1 means a decrementer, means a minus 1. Similarly b, if we go through b, b minus 1, c minus 1, any number we can take it, doesn't matter. How it is defined? Okay, now we see, if we go through a minus 1, then how to define? Very simple way, we define a minus 1 is equal to a, first a, okay, plus what happens? This minus 1 define 2's complement of, very simple way, 2's complement of 1, because it is 1, 2's complement of 1. Okay, that means, what does it mean? How to again we define, because it is a 2's complement, that means a plus, that is 1's complement, 1's complement, okay, 1's complement of 1, okay, plus 1, 1 complement of 1, because this 1 is given, this 1, so 1's complement of 1 plus 1, that is a what? A minus b. You see, very simple way you can define, that is a, you see, a minus 1 means a plus 2's complement of 1, means minus 1 means 2's complement of 1. So 2's complement means 1 means directly you can find out very difficult. So it is better to define 1's complement of 1, okay, plus 1. That means what? Now we will define, that is a plus 1's complement of 1 plus 1. Now we define how it is defined 1's complement of 1. Okay, very simple way we can define. Here you see the question is a 4-bit data. So 4-bit data we define. Now we see 4-bit data we consider here. 4-bit data means suppose 1 minus 1 we define with 4-bit. 4-bit means what? 0 0 0 1. We have to make this negative value of this one. Then what happens? What will do? Then first of all what happens? 1's complement. Okay, 1's complement of 1 plus 1. I have already told in that page. 1's complement. One complement. Okay, 1's complement of 1 plus 1. So 1 is this one. 1's complement. What is 1's complement? You see, very simple way. 1's complement means here that is a 0 0 0 1. 1's complement is how much? That is 1 1 1 0. Just 0 1 1 0. Okay, reverse of that digits. That is a 1's complement. Okay, 1's complement this one, this. Okay, next is a plus 1. So now add 1. This one we just add. What is the value? 1 1 1 1. Okay, this 4 1. That means what happens? 1's complement of 1 plus 1 is equal to how much? 1 1 1 1. Okay, now we can find out how this 1 minus 1 value. Okay, that is a minus 1 value is 1 1 1 1. In this way we can define the minus 1 value. Similarly, if we go through minus 2, minus 4, minus 5, minus any kind of numbers minus, then what happens? We convert to binary form of that number, then apply the 2's complement of that given number, then apply 1's complement of that number plus 1. Whenever convert to 1's complement or 2's complement, then convert to binary form of that number. I have already discussed in last page. Okay, this is the basic concept. So whenever define, that is a minus 1, because we have to define decrementer a minus 1, that means we have to take, that is a plus 2's complement of 1. Okay, 2's complement of 1. That means what? A plus 2's complement of 1 means what? This is minus 1. Minus 1, 2's complement of 1. 2's complement of 1 defined. Minus 1, 2's complement of 1 is a 1 1 1 1. So it is a 1 1 1. Why it is you taking 1 1 1 1? Why 4 digit we take? Because that is the question is given like this. That is 4-bit data. So we consider that is 1 1 1. That means any data we will consider with the decrementer, we just consider 1 1 1 1. Okay. Now we have to design that particular circuit. That circuit we have to design 4-bit circuit, combinational circuit. Here you see, if we go through A, here it is 4-bit, 1 1 1 1, 4-bit. Similarly, A also divide, that is a 4-bit, like we can consider A is like A0, A1, A2, A3. Why I am taking? Because whenever we design that circuit, combinational circuit, having 4-bit, we have to take in this manner. Because A value we just consider normally, but it has that is a 4-bit. Okay, any number, suppose 1, how many bits? 1 is a 1 value, but how many bits we consider? 4-bit consider, means 1 1 1 1. Similarly, if A is a 1 value, but consider 4 parts, A0, A1, A2, A3, like this. Okay, now we will start that combinational circuit of a given, that is a question. The question is very easy, that is you draw or design a 4-bit combinational circuit decrementer using 4 full adder circuits. Okay, 4 full adder we consider that circuits, and based on that we can design that is 4-bit combinational circuit. Okay, now I will start how we design that 4-bit circuit. Now we see very simple way. I explained that particular example. Now design 4-bit circuit. Whenever 4-bit combination circuit, what you use? What is that is circuit name? Full adder. That means 4 full adder we consider. Okay. Now we see very simple way. 4 full adder we consider. Okay. 1, 2, 3, 4. Okay. 4 full adder. That full adder you see very simply 4 full adder. Here is a 4 full adder. Full adder we can consider because that is mentioned in a question. Okay, 4 full adder. Here you see now how many inputs we will provide. You see very simple. I have already mentioned that that is here mentioned is a 4-bit combination circuit. That is whatever the data we have to convert 4-bit. Okay, 4 full adder. Here you will see 4 full adder already taken. Now see 4-bit. 4-bit means we see whatever the data will take, that is 4-bit. For example, a minus 1 we have to consider. Okay, a minus 1. Why a minus 1? Because decrementer. A minus 1, b minus 1, c minus 1, any kind of data you can take. It doesn't matter. Whenever you go through that, then what you do? Here a suppose consider means a having 4 bits like a0, a1, a2, a3, like this we will consider. Another part is whenever add this one, another input is that 4 bits 1, 1, 1, 1, because we consider minus 1. Minus 1 having 4 bit. This 4 bit 1, 1, 1, 1, 4, 1 will consider. Based on that, here one inputs consider from a0, another inputs consider from minus 1, one input, that's 1. A1 1, A2 1, A3 1. Like this we will consider. Okay. Now see how it will be designed. Okay. Very simple way. I will show you this. Initially you just give some inputs, that is 0. Okay. Now I told that is 2 input will provide. Okay. One is A part, another is normal minus 1, 4 bit of minus 1. Minus 1, so very simple. I will show you. It is 1, 2 input. You just put it. 2 input. Okay. This 2 input for each full adder. Okay. One part is what? That is minus 1. One part is 1. Another part is A0. Here is 1. That is A1. Here is 1. That is A2. Here is A0, A1, A2. Here is 1. It is A3. Now you see each individual part. You see very simple way. Each individual part having what? 4 bit. Here 1 bit. Here another bit. Here 1 bit. Another bit. 2 bit. Because we have to decrement. So you have to consider in this way. Whenever it add, it meaning add, because I have told that it's how it will be add. Whenever it will add, then what happens? It transfer the carry bit to another one full adder to another full adder. Okay. Whenever it will add, it will transfer the data from one full adder to another full adder. But whenever add, that is carry bit to add, but it has own, that is a summation of data, sum of data. You can find in this way. Okay. In that case, what happens? We can write S0 because A0 plus 1, that is S0. A1 plus 1, that is S1. A2 plus 1, S2. A3 plus 1, S3. Okay. So whenever add, some carry bit is definitely will get it. Sum is there, and some carry bit also we can get it. Then what happens? Carry bit pass to the another full adder. Then again A1, suppose A0 plus 1 add, sum is there, some carry bit pass to here. Again A1 plus 1 add, again carry bit of previous carry bit add, then what are the after adding the carry bit, then add to the transfer to the sum. Again that carry bit transfer to here. Suppose there is no carry bit, doesn't matter. If you carry bit, then transfer from one full adder to another full adder. In this way, we can draw this full adder, that is 4 bit. Here is 4 bit because you see A0, A1, A2, A3 4 bit, and incrementer, that is 1 1 1 1, like this we can design. Okay, this is the basic concept of that is a full adder, and we design this 4-bit combinational circuit, that is a circuit diagram for decrementer using 4 full adder circuits. Very simple circuit diagram. Once you understand how it will design, then it is easy to design in this particular combinational circuits. Okay, so thank you very much to watch this video. I think that I explained this part very clearly. I hope all of you understand. That is, please, if any things missing, please comment me. I will that is check out that mistake and improve that videos. Okay, thank you very much. Thanks to all to see my videos. Okay, thanks to all, and please subscribe my channel to proceed and to forward my channel further. So try to solve different kind of problems, not computer organization. That is different subject problems. I try to solve and reach to your level, and whatever the possibility, I will collect different problems from different sources and try to solve this one. Okay, thanks to all. Thank you.